Question number 9. Without using a calculator, express the complex number 2 plus 6i over 1 minus 2i in the form x plus iy, where x and y are real. Now then, for this question, we're going to use the conjugate of the denominator to express this number in the form of x plus iy. So what we're going to do is going to say that it is equal to 2 plus 6i over 1 minus 2i times the conjugate of the denominator, which is 1 plus 2i, 1 plus 2i. And again, if we try and do that, 2 times 1 is 2, 2 times 2i is plus 4i, 6i times 1 is plus 6i, 6i times 2i is plus 12i squared, and of course you're going to divide by 1 square minus 2i to the square. Okay, so what do we have? 2 plus 12 times minus 1, because we know that I squared is minus 1, so that's minus 12 plus 10i divided by, okay, so here I've got 1 minus 4, so I squared is minus 1, minus 4 times minus 1 is plus 4. So basically we're saying minus 10 plus 10i divided by 5. So the answer is going to be equal to minus 2 plus 2i. Here we are. If we check it on our calculator, which we're not allowed to use this calculator in exams, just for verification, here we go. Take care. Second part to this question, hence, without using a calculator, express 2 plus 6i over 1 minus 2i in the form r into cos of theta plus I sine theta, where r is greater than 0 and minus pi less than theta less than or equal to pi, giving the exact values of r and theta. And now we need to express 2 plus 6i over 1 minus 2i in the form of r, cos of theta plus I sine theta, without using a calculator. Okay, of course this is the polar form or exponential form. Alright, first of all, we need to realize that this is basically minus 2 plus 2i. Now, it's very interesting to illustrate this on a diagram, on an organ diagram. And it goes like this. So this is like minus 2 and 2i. So we've got 2i and minus 2 is here. So the argument is this one. There, that's the argument. Now, if I want to find the argument is theta. So argument is basically, let me just call this theta. Alright, so the argument of this complex number is going to be tan inverse of 1, and that's going to become minus plus 5.4. Then what you do, you take away, we're trying to find this theta, alright, so then the argument is going to equal to the whole thing, pi minus 5.4. Now that's the argument, that's what we are talking about, 3/4 pi. So this is theta. Alright, I mean this is not really theta, but that's the other part of the angle. We may call it theta as well. Anyway, let's move on to find out this length here, the modulus of r. So that's, we can use Pythagoras theorem. So basically we're saying 2 to the square plus 2 to the square, which is square root of 8, and that is square root of 4 times 2. Well, square root of 4 times square root of 2 is 2 root of 2. Right, so therefore the complex number can be written as this here is equal to 2 root of 2 into cos of 3/4 pi plus I sine of 3/4 pi. So here we are. That's your answer to the question. Take care. Part B of the question. On a sketch of an organ diagram, shade the region whose points represent complex numbers z, satisfying both inequalities, mod of z minus 3i being less or equal to 1, and a real number z being less or equal to 0, where real number z denotes the real part of z. Find the greatest value of the argument z for points in this region, giving your answer in radians correct to 2 decimal places. And now for the last part of the question, we need to sketch on an organ diagram z minus 3i being less or equal to 1 and the real part of z being less or equal to 0. Now if we look at this complex number here, we need to understand what this number is. Minus 3i can be bracketed being less or equal to 1. So we've got a circle with center 0, 3 and radius is equal to 1. So let us say, suppose this is 3. So we got then like radius is 1, so 1 here, 1 here, 1 here, perhaps, okay, 1 here. So if we were to sketch, we're going to get a circle like this. Pardon me for my drawing. Circle is not looking very good there, but that's okay, as long as we got the idea. And also the real part being less or equal to 0, real part of z being less or equal to 0. Okay, this is like the x-axis being less or equal to 0. Okay, the line x is equal to 0 is the y-axis. So if we were to shade, you need to shade the region within the circle because it's less than 1, so the shaded region is going to go in here, even there. But now why are we taking only one part? Because if we were to shade this one being less or equal to 0, it's like this. Okay, see here. Hang on, let me just put it a little bit up here for you to be able to see what I'm doing. Okay, you've got something like this. Okay, and you've got the circle here, and you're shading in the circle, so you got double shading there, and that's why the answer is this one. And then we need to find the greatest value of the argument of z. So the greatest value of the argument of z lying in this region would be somewhere here. You can have the argument going like this. We'll still have a point somewhere there within that region. Okay, so there. And of course now you can draw a radius touching that tangent, and that's going to be 90 degrees. And again, what do we know about this? That if I were to remove this now outside, I'm going to get something like that. Just to show you, okay, that this is the radius one, this is 3. I can find this angle, let me just call it gamma. Okay, so what we're going to do, we're going to try to find gamma, and this is the hypotenuse, that's the opposite. So sine inverse of 1 upon 3 is gamma. And take our calculator here. Sine inverse of 1 over 3, 0.33836. And it's going to go on forever. Also we've got this here, 90 degrees. The 90 degrees is pi upon 2. So the maximum argument of z, or the greatest argument, okay, value of z is going to be pi upon 2 plus what we've just calculated. So let's do that. So plus pi upon 2. Just hang on a second. Okay, plus pi upon 2. 1.9106. And and therefore I can say that the maximum argument of z is going to be 1.91 to 2 decimal places. That's it. So this is our question completely done.